Hello everybody, video tutorial for the S60-105 CAD for the rod end. Okay, so this one's going to be your first one. You're going to do some revolve features. You're going to use the hole wizard and you're going to make some extruded features. Alright, so let's go to our drawing and take a look at it and see what strategy we're going to take on this one. So our front view, we want it to be this ultimately. So we would want that to appear on the front view of the sketch plane. And in this top view, it's apparent that it's got rounded edges with some flats cut on it. So that would suggest that we probably should start off with a Revolve Base. You don't have to. There's more than one way to make this. But I believe to make this part with the least number of features, we'd start out with a Revolve feature that would represent the silhouette of the part in the top view. So it would just be these outside edges, and then we build all the other features as we go on the model. So this would be a multi-feature model unlike the last few you've done. And we come back and use the hole wizard for the end hole, and we could use it for this hole on the tab, or we could use extruded cut, either way. We would want to use the drill hole wizard so that we get the cone point that's allowed for that particular hole. It's allowed to be a blind hole with a tip, drill tip there. Okay, so the important dimensions we have here is the 300 thousandths long with a radius of 0.189 on the radius, which corresponds in the diameter of the width of it being 0.197. So we need those three numbers to start our base feature. Alright, so let's go to SolidWorks. And again, we're going to open a new file. We're going to say OK. And it'd be best practice to save this off initially as its name. Okay, and we're going to go and we're going to make our planes visible. And we're going to do a sketch, and we're going to start that sketch. Oops. Wrong icon. When we're in sketch mode, we're going to put sketch. We're going to use the front plane. And I'm going to start off with a line that's horizontal, intersects the next plane. We'll use the arc command. So I'm going to put my center line somewhere on here because it's not a tangent arc. And we're going to snap to the end of the line. We're going to snap to the center line. We do not want the tangent relationship here because they are not tangent in the drawing. Okay. Alright, so if we go back to our drawing, actually I'm sorry, let's go ahead and do our revolve center line, and that's going to have another purpose, which you'll see here, than it did in the prior ones. Okay, so I've just made it horizontal, and it terminates the same point as the end of the part. Now there's a handy thing with dimensioning in SolidWorks. If you're doing something you know is going to be revolved around a center line, you already have that made, you can select the center line, select your entity for a radius, and if you drag your cursor down below, it assumes you want to put in a diameter number. But you have to have the center line involved. So we can go ahead and put our diameter in just like the drawing shows. So the diameter is a 0.97. I suspect that's a rounded out fractional size, but 0.197. And then it creates our dimension as a diameter for that radius. Okay. Now we come back and we're going to put a radial dimension on the radius of the end, and that is 0.89. 0.189. radial dimension, so that gives us our radius on the outside. Now this component was 0.3 long, so 300 thousandths long. So we're going to go from the endpoint to endpoint and punch in 0.3. So that's looking more of the scale of what the drawing is. Now in this case we're making a complete solid, so we need to enclose our solid to have two more solid lines. Now you can in SolidWorks use the second line I just drew as your revolution edge. Doesn't have to be center line, but I believe for this dimensioning tool it does have to be a center line there present for that associativity. Okay, my sketch is fully constrained. I can now exit the sketch, go to a three-dimensional isometric such view, and we're going to go to features. We're going to make a Revolve Base, and it should preview it. Looks like it made an assumption off the center line that was there, so that's good. You might have to select it. And we've got our initial piece. Okay, so now we're going to build it just like the drawing. So if we were to look at this in the front view, so if I select front view and I select the icon that says normal 2, I'll be looking at this in the front view. So what do we see in the front view of our drawing? We see this is notched out with a 0.063 thick tab. So we need to remove the material that's in those two locations to make up this tab. So you can do that in a variety of ways. I'm just going to go ahead and do it in the front view with a sketch of a rectangle and another rectangle to cut that material away. And we just need this dimension and the one on top there. Alright, so let's go back to SolidWorks. Here's the center of our part. I'm going to sketch a rectangle, and I'm going to intentionally try to avoid things that would give me an auto snap. Okay, so I've got two rectangles. They're not defined how far apart they are. I want to go through and I want to make some relationships between the two rectangles. So I want the two lines there to always be collinear. I want the two lines in the back to be collinear. So no matter what dimension they are, they'll be collinear to each other. And remember, this is a drawing material we're going to remove. So to constrain it, we need a dimension for the width of the tab, which was a 1/16 of an inch. So 1 divided by 16 gives our 0.06. If we expand the tolerance out, we'll see that's 1.63, which is what our drawing is. And then we need our dimension of 0.079. So we're going to put a dimension from the back of the part to one of the rectangles. That's 0.079. We expand the tolerance. That should show the same decimal points. Now this right now isn't centered. There's a variety of ways you can do it. You can do it with a dimension. You could do it with center lines. I'm just going to throw a dimension on the top rectangle and drag off to the left. And it's going to be 1 divided by 32. So it would center it. Alright, so we have everything constrained except for we need to give the boxes some sort of dimension. So I'm going to dimension the length on the lower one, which should cover them both. And I'm just going to take the default. And then we need to dimension the height of the box. So I'm going to pull that out and take the default. And then there's just one blue line, and that's because this width isn't defined on the top rectangle. So we go Shift or Control or Shift, select both those lines, and if I make them equal in length, we should have a fully constrained sketch, but it looks like we don't. So let's take a look at what is not right. Oh, interesting. I just had to rebuild. It was fully constrained, but it rebuilt and the negative symbol went away. Okay, so we're fully constrained. So you can think of those as like two cookie cutters that are going to remove all the material in the view we're looking at through the solid model we already have. All right, so let's go to a three-dimensional view. I've drawn those on the center line plane. So what I need to do is I need to cut in both directions. Okay, so if we exit sketch, go to features, we're going to do an extruded cut, and we're going to use the last sketch we made. And it defaults to going a distance from one side. So what we want to do is change that to through all, because no matter how big our part gets, if we change it, we want it to go through the entire part. And we want to cut in two directions. And we want it to do through all in both directions. So it's like the cookie cutter starts in the center of the part and is going to radiate out in both directions. So in those yellow zones, material is going to go away as soon as I hit OK. So we're going to hit OK on that, and we have now the tab created. At this point, I am going to go ahead and hide the planes. Not so sure they're all that necessary, because now we'll be picking on planes of the actual part for making features. All right, so the next feature I'd like to put in is let's put the hole in the end. And so we need to go back to our drawing, and we have a 0.094, so let's write this down, 0.094 to 0.099, which is a 5,000ths difference. So we're going to be looking at the drill charts to see if we can see something that's close to center, the tolerance on that. Okay, so, and it has a 0.04 max depth, so we're going to put in 0.04, but that's the maximum depth that this drill bit can go, and that's to the shoulder. And I think there's some concern about strength in the area. If the drill bit goes too deep, we lose strength in the tab. We don't want the drill point going through. Okay, so let's go back to SolidWorks, and we're going to use Hole Wizard. We're going to be doing a plain hole, nothing fancy. And we're going to look at all drill sizes. And I want to show the decimal values so that I can see what those are without having to know. And we were looking for something at 0.099 to 0.094. Okay, so we got the 39 drill, which is 0.099. And then we have the 40, that's 0.098. And we have the 41, that's 0.096. So either the 40 or 41 drill, I would go with the 41. The intent on this component, I believe, is that it's press fit, so going a little smaller is probably better. And we don't want any countersinks. And the end condition, we don't want through all, we want blind. And if you recall, we were going 40 thousandths deep, so 0.04. Okay, and then we're going to select the plane we're making our hole in. Go to positions, select the plane the hole is going to be in, and you're going to get this hole that you can move around. Fortunately, ours is right on origin, so we can just select that and select OK. And we now have the hole cut in the end for number 41 drill, and that's noted in here. So when we go into machining, we're going to know exactly what size drill bit we need to select. Okay, so now let's put the hole in the top side. Now in this case, we would need to set up a sketch ahead of time. So whether we use the hole wizard or not, we're going to make a sketch. So go to sketch, sketch mode, sketch, and we're going to select on the top of the part as our plane. And let's go ahead and look at that view normal to the plane we selected. So we're looking straight down on it now. If we were to pull our drawing up, we're going to set up a sketch that puts the hole on center line at a 230 thousandths from the end, and it's a 65 to 63 thousandths. So if we shoot him halfway in between, that'd be what, a 64 thousandths hole. So let's just go ahead and do this with a circle, and we're going to go to SolidWorks, and we're going to make a point. We're going to put that point on the plane, and we'll do a dimension just like the drawing from the back of the part. That's 230 thousandths. So from the back edge of the part to this point, we have 240 thousandths. Okay, we go back to our drawing. I'm sorry, it was 230 thousandths. And then we want it in line with center line. So we can go from origin, draw a center line that goes to the midpoint of the edge there. And then we can take that point and highlight it with the control key down with the center line and make those coincident. And everything turns black. That is the center of our circle. So we can go with the circle command, select our point, draw our circle, and we need to give it a diameter of 0.064. There we go, and it changes the size. Now let's look in 3D what we're doing. So we're sketching on this top plane. We want to make a cut all the way through. And thinking ahead, if we're going to design this part differently, we would want to make sure that if we change the thickness of the tab, that the hole always goes through with our design intent. So we're going to go to features. We're going to do an extruded cut, and we want it to go through all. And so no matter what size the part becomes, that part goes all the way through, that whole feature goes all the way through. Alright, so we've got everything done. This is the Dash 105, and that should have been pretty straightforward. You can assign the material as brass if you like, and don't forget to submit it in Canvas on time. Alright, thanks a lot, and I'll catch you on the next video.